Hello everyone, my name is Kyle Monahan and I'll be taking you through how to use the interactive app for your class. This is for the Data Science for Sustainability course, cross-listed in both mechanical engineering and computer science at Tufts University. I'm a senior data science specialist here at Tufts, and I'm walking you through what we've created here for you. So the interface you see here is called OnDemand. It is the portal or the graphical user interface, aka GUI, for the Tufts High Performance Compute Cluster. This is similar to any other compute clusters that you might have used if you've spun up a large compute on something like AWS or Microsoft Azure. But this one is on Tufts campus, on Tufts premise, and well, it's free for you to use as a student here, and so you might as well utilize that. What we have provided to you are graphical interfaces to a series of interactive apps. What these do is they allow you to create an interactive session with a specific node on the cluster. You can think of the cluster as many computers tied together in one. This allows you to request a section of that multi-core computer, and use some of that compute power for your needs. I'm actually logged into the VDI here, which you'll be able to do. What you can do is you'll see Jupyter prod for ME193. That is for your class. You're welcome to use it if you're in the computer science designation of that class, but that's you can certainly click on this. It's just labeled with the ME designator. If you click on this, what you'll see, once I click on this in a second, there we go, you'll see that it's going to have a couple forms for you to fill out. What it's requesting here is the number of hours you want to stay interactive. Now I suggest you keep this below 6. Really what you should do is get on and perform your analysis and ask for enough memory to do it interactively. So to sit there and kind of iterate through your analysis. There are other ways to send commands to the cluster that we can talk about later in the course, but you could put up to say 5 hours here. In my case, I'm going to put 2 just because I'm testing here today. I can go up to 74 cores. For me, I'm going to start off with 18. I can go up to 256 gigabytes of RAM. I'm going to go with 16 just to get about a laptop worth of compute here. I can choose my Jupyter R and Python version. In our case, I've set them to be consistent throughout your class, just because so everyone will be on the same version of everything. Finally, you don't have any reservation for this class. You can just click launch. And what this will do this is now requesting a session with the cluster. The session was successfully created. So now it's waiting a little bit. It might be that a lot of people are using the cluster, so we just wait a little bit. The cluster operates on a queuing procedure. This is actually organized by something called Slurm, which organizes the jobs. And so many people can submit jobs to this very same cluster, and they're given allocations in the order that they submit them. So in our case, we submit this request to access these resources, and we wait a few seconds while this works. Now your session is currently starting. That means that will take just a few minutes, maybe a minute or two, sometimes less, for this to actually start up. We can say connect to Jupyter, and now we are connected in our home directory on the cluster to the Jupyter instance. I can see that this URL here, ondemand.cluster.tufts.edu/node/node name /process ID/tree this is giving me the node name on the cluster. That's equivalent to the machine on the cluster that I've been given resources on. In this case, I've already made this untitled.python notebook. If I wanted to, I could also go to New Python 3 Notebook and get started. I also want to note that I can access a terminal through here. This allows me to access that Omega 018 node, the same as what's noted up here, through a command line. I can ls -la, and all of my traditional Linux commands that I might know if I know Linux. If you don't know Linux, I strongly suggest, if you're interested in learning about data science, to learn some Linux command line. It is one of the #1 skills. I write bash scripts probably, at least a few times a week, if not editing them daily, and it is a great skill set to have. So you can run your analysis in here. You can import things. You can import mail, import sys, print sys.path, right? And I can see this is the current path context in which I'm operating on the cluster. So I can see that I can write Python code and get iterative responses here, right here in this notebook. If I want to rename it, I can say testing for ME193, and so on. So this is how you can access and work with the environment that we've created for you on the cluster. One thing to note is if you go to Files and Home Directory, right on the Home OnDemand application, it will open a file explorer. And you might note that testing for ME193 IPython notebook, if I click on that, I can download it. So if you want to download anything from that home directory, you can do so. One other pro tip that I have is you might see here that I have these little teal icons here called Data Lab and Scripts. If you have access to other storage on the cluster, you can create something called a symlink to that storage. For me to figure out what a symlink is, I can just look up symlink Linux, how to create a symbolic link. That's also called a soft link, and that allows you to link to different file locations, which makes it seem as if the folder is there. It's a direct link to that file or set of files. In my case, that allows me to, from this home page, go directly to this directory and see all of the files within there. It's quite convenient. And we'll go through that a little bit during the other videos I'll create for this. But this is more or less exactly what we would expect you to use and what you'll use for your time in this class. Thank you very much for listening, and I hope that is helpful. Thanks a lot.